So the first thing that you have to remember is what molarity is. And so molarity, symbolized with a capital M, is going to be your moles of solute divided by the liters of your total solution. So if we were to rearrange that, we could say that the moles of our solute is equal to our molarity of the solution times the liters of the solution. So remember that liters of the solution is the volume. And so we can say that the moles of the solute is equal to the molarity times the volume of that solution. So if you remember from our last video, if we have a solution like the one we have right here, where we have 5 moles of our solute, and we dissolve it, or we dilute it. So if we add some solvent to this solution, then we're going to have more of our green. We'll have diluted it, but there's still going to be 5 moles of solute there. Okay, so this is the dilution. We still have the same number of moles of solute. So what does that mean? That means that the total number of moles of a solute doesn't change in a dilution. And the reason that that is very important is that it means that the molarity of our beginning solution and the volume of our beginning solution can be used in an equation to determine information about the dilution. So if I go into the chemistry lab stock room, I am gonna find materials that have a particular molarity. So let's say I go in and I want to get some hydrochloric acid. Well, most of the time, the strongest hydrochloric acid that we can get has a molarity of 12. Well, I'm never ever going to have students use that in the laboratory because it's just too strong and it's dangerous. And so what I'll do is I'll find out how do I dilute this? And so because the number of moles never it doesn't change when we dilute something, I can set the fact that molarity times volume of my stock solution is equal to the new molarity I want to get and the new volume that I need to have. So if I have a solution that has a molarity of 12, and let's say that I get a volume of I grab 10 milliliters of that solution. And let's say that I need my new solution to have a molarity of 1. Well, you can see that I only have one unknown variable now, which is my new volume. So I can solve for this new volume here. So 12 times 10 is 120 is equal to 1 times V, 1 molarity, divide both sides, which would mean that I would need to increase my volume to 120 milliliters. So if I already have 10 milliliters, if I take and I put 10 milliliters of this very strong 12 molar solution into a container. So I've got 10 milliliters of it, and it's at a molarity of 12. Well, according to my calculation right here, I need to get my volume up to 120 milliliters. That's going to be my new volume in order to have a molarity of 1. So that means that I'm going to add to this, I'm going to dilute it with water or whatever my solvent is. I'm going to dilute it with water, and I'm going to add 110 milliliters of my solvent, of my water, where I'm going to add water until I get up to that volume of 120. I've already got 10 milliliters of the very strong solution. So I'm going to add 110 milliliters of solvent so that then when I'm done, my ending beaker is 120 milliliters of solution, and that new solution will now have a molarity of 1. So what I'd like you to do is load the PDF and try out the practice problems, and then come back to this video and see how you did on each of the practice problems. So with these problems, the key is going to be making sure that you keep the molarity and volume of one particular solution together and the molarity and volume of the other particular solution together. So if I look at this first problem, it says how much concentrated 18 moles sulfuric acid is needed. So how much? So I don't know this volume, but I know this molarity or concentration is 18, is needed to prepare 250 milliliters. So this is a different volume, so I'm using a different color to highlight it. And my molarity that goes along with that is 6.0 moles per liter. So this one that I've circled in red goes with this volume here. So 250 milliliters times a molarity of 6.0 is equal to an unknown volume times 18 moles per liter. So now I'm going to solve for my V. So if I divide both sides by 18, I can solve for my V by taking 250 times 6.0 and divide by 18. So my new volume would be 83.3. My units would be milliliters, since my units that I started with for volume was milliliters. So 83.3 milliliters is going to be my new volume. So if I was in the laboratory, I have 250 milliliters of a solution with a 6.0. I actually am going to need to only, if I want to make this solution, I only want to go into my stockroom and get 83.8 or 83.3 milliliters of that really strong 18 molar solution, and then I'm going to pour it. I'm going to pour 80, I'm going to measure out 83.3 milliliters of it, and then I'm going to add water to it to dilute it, and I'm going to add water until I get up to 250 milliliters. So I'm going to have to add whatever 250 minus 83.3 milliliters. I'm going to have to add that much water to dilute this. On the next problem, I have 12 molar hydrochloric acid, just like my example at the beginning of this video, and it wants to know how much of that am I going to need to go and get. So I've got 12 molar solution, and I don't know how much I'm going to need to get, and I want to make 100 milliliters, so I'm going to set that equal to 100 milliliters of, I want to make a solution that only has a concentration of 2 moles per liter. So I want to solve for V, so I'm going to divide both sides by 12 in order to find out my volume. So I'm going to do 100 times 2, and I'm going to divide that by 12. So 200 divided by 12 is 16.6 milliliters. So again, my volume that I want to get to is in milliliters, so my answer is going to be in milliliters. So I'm going to go to my stockroom. I'm going to fill up a beaker with 16.6 milliliters of this really strong solution here, and then I'm going to add water to it until I get up to 100 milliliters. So I'm going to have to add, what is that, about 83.4 milliliters. Until I get all the way up to 100, I'm going to add water to that, and my new solution will have a molarity of 2.0 moles per liter. So maybe pause the video here, see how you're doing on each of these problems, and then come back and check your work to see if you did them correctly. So for the next one, if I go into my back storeroom and I grab 25 milliliters of a 15 molarity solution, I would have to add 100 milliliters of water so that I would get up to 125 milliliters for my new volume to get that diluted down to a 3.0 molarity. How did I know 100 milliliters? Well, I went into my storeroom and I got 25 milliliters, it says. So I went and got 25 milliliters. Well, my new volume needs to be 125 milliliters. So I'm going to add 100 milliliters of water to this so that my new total solution is 125 milliliters. So that's going to be my new volume is 125 milliliters. All right, on the next problem, it says that I'm going into my stockroom, I'm getting 50 milliliters of a 12.0 molar solution, molarity solution, moles per liter, and I want to dilute that down to being only 4 moles per liter. So I've got it all set up and I find out that I'm going to need to increase my volume to 150 milliliters. But this question says how much water should be added. So here's where I'm going to have to answer and figure out. So remember, I went into my stockroom and I got my beaker of my solution of 50 milliliters of it, okay, of the 12 molar solution. Now, in order to get it diluted down to this 4 molarity, I need to increase my volume to 150. So that means I'm going to have to add solvent or water until I get my solution up to 150. So how much water am I going to have to add? Well, I already have 50 milliliters of solution. I need to get up to a solution of 150 milliliters. So that means I'm going to need to add 100 milliliters of water in order to dilute that. So that's my final answer right there, is 100 milliliters of water has to be added. Now the next problem asks you to do the same thing. So I'd like you to go ahead and try and do this one on your own and then come back and see if you did it correctly. So for the last problem, you should find that your final volume has to be 1200 milliliters, but it wants us to figure out how much water should be added. So remember, I went into the storeroom and I got 100 milliliters of this solution. So what I have to do is I have to add water until I get up to the solution of 1200 milliliters. So 1200 milliliters minus that 100 that I already have, that means I'm going to have to add 1100 milliliters of water needs to be added in order to get the solution to the correct molarity in order to dilute it. So here is my final answer with that one. Go ahead and take the quiz on these problems and see how you do. And if you do poorly, redo it if you need to.